in bio-inspired innovation. From 2009 and 2017, she was a transition research coordinator at the Flemish Institute for Technological Research. Now, she's certified in transition thinking, biomimicry, and permaculture. In permaculture design, and is a regular teacher in the Next Works Innovation Bootcamps. Leen has organized innovation sessions to learn from nature in San Francisco, Auckland, Copenhagen, and several other cities, taking bankers, executives, and designers into the woods to elucidate the regenerative nature of innovation. 2 years ago, she was here with us in a workshop with several companies. So, thanks a lot, Leen. The floor is yours.
Thank you so much for that nice introduction. And let me start my keynote with saying that even though we have designed some pretty amazing things and stuff, we are not such good engineers, managers, and designers as we think we are. A few examples. Our entire industrial system performs at less than 10% efficiency. Our food system consumes 10 times as much energy as it actually delivers us, and it's now raining plastic. So I can give many more examples. I think you all know these examples. They're just to show that the traditional way of innovating is eroding nature, and not just what's out there, but our nature too. So it's clear that we need a new paradigm for innovation. But where can we look for inspiration? We can scan the cosmos and look for intelligent extraterrestrial life, or we can bet on artificial intelligence and hope that ET and AI will spare us, which many great minds like Stephen Hawking think is very unlikely given the human-induced deterioration. And while artificial intelligence is still in diapers, natural intelligence is 3.8 billion years old. What that means is depicted in this picture. If we would summarize the history of the Earth into one calendar year, then all of human history would take place in the last half hour of December the 31st. The Industrial Revolution would start only 2 seconds before New Year's Eve. So as relative novices on the Earth, our biggest challenge is to avoid joining the 99.9% of species that once inhabited the Earth but are now extinct. Or to use the words of Jonathan Porritt, who is the co-founder of the Forum for the Future, maybe it's time we consider living on the Earth as if we intend to stay here, by learning to become self-renewing right where we are. Because in nature, those that resist evolution, they go extinct. So I propose that what the world needs right now is not artificial intelligence, it's natural intelligence. It's about the logic that has stood the test of times. Because there are organisms and cooperatives that have been around for millions of years. They withstood generations of change and disruption, and they colonized every part of the world. They built superhighway networks that not only exchange information, but also energy and healthcare systems. And it's called the Wood Wide Web. It's nature's internet, and it's 1 million years old. And it also feeds an entire ecosystem of creatures in the process. Some species, like mushrooms, even invented strategies to make it rain. So these ancient organisms, they continuously upgrade their environments, and they thrive as a result. Did you know that land that is inhabited by termites is much more resilient to climate change than land where there are no termites? Because the termites, they store moisture, they store seeds, and they store nutrients in their colonies. So when heat waves strike, the termites help the land to regenerate much better and much quicker. And these ancient organisms, they're pretty successful, because if we would weigh all the ants in the world today, they would weigh as much as all of humankind. If we would weigh all the termites in the world today, they weigh 27 times as much as all of humankind. Now, these ancient creatures, they invest in future generations by investing in the planet's life support system. They feed the life that feeds them. And while there are many examples of competition and predation out in the world, we now know that the prevailing relationships in nature are cooperative. So forget about the struggle for survival. Long-term evolutionary success is much more about the snuggle for survival. And while millions of years of selection turned failures into fossils, the designs, the patterns, and the organizational formats that surround us, they have stood the test of time. They have survived despite generations of change and disruption. The difference is not in what we want to achieve, it's simply in how we do it. This is a city built by amateurs, and this is a city built by professionals. Our cities are built on a resource that is called cement or concrete, and the cement industry accounts for 6% of the total annual greenhouse gas emissions, while the cities created by nature, the coral reefs, for instance, they store carbon, and they have been around for more than 400 million years. What's more, in our cities we have a lot of problems like smog, traffic jams, unemployment, homelessness. In Nature's city, everyone has a job, everyone has a home, and there are no traffic jams and no smog. So which one is the smart city? Now, nature is not perfect, and I think we humans are the best examples of this. But she is constantly perfecting approaches for survival. And as our understanding of the natural systems grows, it is overturning the way that we are thinking about change, innovation, and sustainability. Because once you really know how life works, you will see that sustainability is the byproduct of regenerative value creation. And I use as a definition for regeneration a process of renewal that leads to a higher order of health, wealth, vitality, and viability. So as a species, we will only have a future if we learn to develop ourselves and our world regeneratively. And that is what natural intelligence is about. Nature knows what works, what lasts, and what contributes to life on Earth. So this means if we would harness natural intelligence, that we would look at nature as a mentor. For instance, for bio-inspired innovation. Can we learn from this humpback whale how to increase energy efficiency? Well, humpback whales, they're really large animals. Still, they can take very sharp and short turns in the water because they have these bumps on their flippers. So a company called Whale Power has imitated these bumps that the humpback whales have on their flippers into the blades of a wind turbine. And guess what? Energy efficiency goes up 10 to 20% just by imitating the natural solution. Can we learn from cacti how we can passively cool buildings, so passively without the use of air conditioning, in warm areas? Well, if you look at a cactus, it shades, and it enhances the heat radiation. So the warm air goes up on the ribs that are exposed to the sun, and the air goes down on the ribs that are in the shade. So there's a continuous ventilation around the cactus, and that's why a cactus can live in a desert. So at the University of Science Education in Arizona, architects were inspired by the cactus, which is a local native plant. Can we design a campus that, like the cactus, enhances heat radiation and cools itself? Or can we learn from a tree how to be much more efficient in our material use? Have you ever wondered why trees can still stand up even though they're very crooked? That is because they use an algorithm that says put extra wood where there's most mechanical stress. So if you take that algorithm and you combine it with an algorithm derived from bird bones, birds need to be strong but also lightweight. So the algorithm in bird bones is don't use material where it's not needed. And if you combine those two algorithms and program them into a 3D printer, you can print a table that is as performant as a conventional table, but uses 1,000 times less resources than a conventional table. Or can we learn from sharks how we can create antibacterial surfaces so we don't need any antibiotics anymore? Well, there's a company called Sharklet Technologies in the US that create a film and a surface texture that imitates the microscopic structure of the shark skin, and thereby bacteria cannot attach to medical equipment, to door handles. And so this is a potential very disruptive innovation because we don't need any antibiotics anymore if we can design our hospitals in a way that bacteria cannot live there. Or can we learn from birds or schools of fish or swarms of bees how to self-organize without central management? Well, there's a company in California called Waggle. They're inspired by the way that bees communicate, and they have no HR department. They have no planning department. All employees are self-organized. So the employees decide when they take holidays, who manages every project and how the projects get managed. How do they do that without an HR department and a planning committee? Well, just follow 5 simple rules, inspired by the ways that bees communicate. Their 5 simple rules are: put family first and team second above individual gain. Be humble and respect others. Act with honesty, thrive with change, be excellent and never give up. That is enough for the whole company to self-organize themselves, and because there is no HR department, every employee gets a bigger wage because you don't have that much costs to organize everything. Another feature of natural intelligence is that the chemistry is life-friendly. That means that it's biocompatible and biodegradable. So, for instance, can we learn from a mussel how we can create a super glue that is non-toxic? Again, there's a company called PureBond that imitated the chemistry of the mussel glue, and they created a glue that is formaldehyde-free, and so not toxic. Can we learn from the corals how to use carbon as a building block? A company called Blue Planet is actually mimicking that process, and they create now a cement that draws down carbon from the atmosphere, that stores carbon, that sequesters carbon instead of emitting it. Can we learn from a gecko, which is a small animal that can walk the ceiling, how we can make medical tissue adhesives that can stick and unstick without damage and that are not non-toxic? So how does the gecko do that? He has tiny hairs below his pose, and they make tiny, tiny forces to the ceiling. Millions of tiny forces create a superpower that can defy gravity. There's a company called Gecko Biomedical that imitated that technology of the gecko to create medical adhesives that are biocompatible and biocompostable and non-toxic. Can we learn from nature how to fabricate things instead of the heat, beat and treat methods of manufacturing? Because nature grows its structures. So for instance, mycelium technology, there you look at, can we use mycelium to grow packaging, grow materials, products, insulation? There's a company in New York called Ecovative, and they're doing that. There's another company called Glims in Belgium, and they're also doing this. Or even in Eindhoven, or close to Eindhoven, there's a biology fab lab, which is growing a bridge, just to see if mycelium technology can do that. But we could also learn from bacteria how to grow things. There's a designer in the UK called Susan Lee, and she grows leather jackets. And actually the process is so simple that you can do it in your own kitchen. The only thing you need is vinegar, sugar, kombucha tea, yeast and water. And the bacteria will grow the leather that you need. Or Biomason, another company in the US that grows bricks. So there's no heat, there's no energy used, just nutrient-rich water with bacteria and sand, and the bacteria glue the bricks together. And there's no CO2 emissions. And in this area of bling, maybe we can learn from the scarab beetles how to create coatings, materials, and reflectors that look like gold or silver, but are entirely synthesized from organic components. If the beetle can do it, then surely we also can imitate that process. Now, natural intelligence also means that it builds on the increasing science that nature not only makes us healthier, she makes us smarter and happier too. So instead of designing nature out of our built environment, we should design nature in. This is an example of Belgium, the Children's Psychiatric Center in Genk, created by Ozar architects. Or this is another example, the Triodos headquarters. It's a bank office built by Rauw architects. It's completely reusable, so every part can be reused, and it supports the ecology of the landscape. Or even better, the example from Boeri architects, the Liuzhou Forest City in China, that supports not only 40,000 trees, but 1 million plants in an urban environment. And most of all, applying natural intelligence is about using the logic of life. Because it's only an investment if it leaves the world better off. And the last example from the business world that I want to share with you is one of Interface. It's a carpet tile manufacturer, so they make carpets like here. But their founder had an epiphany back in the year 1996. And he said, wow, if business is really destroying the planet, then we're doing business the wrong way. There needs to be another way. And so he said, I want to be a company that heals the planet, not destroys it. And he sets about his mission called Mission Zero. So by the year 2020, the carpet tile manufacturer wants to be zero negative impact on the environment. Now they're a big company. They employ 3,500 employees worldwide, and they have a turnover of $1 billion a year. So how did they do that? How did they step into that process? Well, first off, they hired a biologist and they said, okay, we create floors. How does nature create a floor? So the biologist took them out into the woods and she said, okay, what do you see? And what they noticed was entropy. On the forest floor there is organized chaos. And so they copied that principle into the design of the carpets, and they created the entropy carpet tile. So every tile has a different structure, different color, but can actually go everywhere. So it's not like this floor, which is uniform. So you prevent a lot of waste with the installment, and also you don't have to keep extra tiles if something goes wrong and you have to replace a certain color of tiles. Then they said, we also want to become an example in the circular economy, and we want to completely reuse the old carpets and make new carpets out of them. But they had a problem. The glue is toxic and it prevents the reuse. So again, they asked the biologist, and well, they imitated the gecko technology. So just glue the tiles together without glue, adhere them, just like the gecko does with tiny forces, so you don't need any glue anymore, and all the carpets can be recycled endlessly. Then they said, okay, now we have a circular model, but how can we create a factory that functions like a forest, a factory that produces oxygen, that supports biodiversity, that recycles all its nutrients, and that stores water. And they're actually building one right now in America. So you see, Interface used nature as inspiration for the way they redesigned their products, their processes, and their systems. And they achieved a really good result with that. Worldwide, their greenhouse gas emissions went down 96% already. The water use went down 88%. And so they said it's time for a new mission. Instead of being zero impact, we want to create positive impact. And so they set out a new mission. It's called Climate Take Back. And I have a little movie clip that gives you an example of this. So in their sustainability journey, Interface got itself into trouble because they got, instead of return on investment, they got return on reputation. So the demand for their more sustainable carpets was much higher than the recyclability of their floors. And they didn't want to use any more virgin fossil fuels or fossil resources to create carpets. So they said, okay, is there a waste stream that we can use to create new carpets? And one of their employees came up with the idea of fishnets. Fishnets are made of the exact resource that they need for their carpets. And so Interface started to pay fishermen to... Sorry, I have to take a sip of water. So Interface started to pay fishermen to fish for fishnets, which they turned into carpets. And part of the revenue they raised, they reinvested in the local fishermen communities to help them restore the mangrove ecosystems so that in the future these fishermen can fish for fish again. So you see, investing in sustainability for this company was a really, really smart decision because their return on reputation has been so high. They have so many clients coming to them wanting to work with them. But even that is not enough. They said, okay, we want to even do more. We want to take or to bring our climate back. And so they are now developing a carpet tile that stores carbon into the carpet. So after the carpet tile is manufactured, there will be less carbon in the atmosphere than there is before. So Interface shows that doing well by doing good, that it can be done. And now that we know that sustainability is the byproduct of regeneration, we need to rethink our role as humans on this planet. And so I want to end this session with a personal example where I've set up a garden experiment at home, because regeneration, it actually really starts at home. So when we bought our house, the land that came with it was very degraded and poor. This is a picture when we bought a house. There was a lot of pesticide and herbicide use, so apart from grass and a few bushes, not much lived there. When we dug a hole, we found only one earthworm, so it was a very poor ecosystem. And so we said, okay, can we regenerate this land using natural intelligence? So disciplines like permaculture, biomimicry, regenerative design and development. And so this is a picture taken in 2016, and this is a picture taken in 2018. During the heat wave, when we had very little rain for weeks on end, you can still see that the part that we regenerated was actually very, very green. And so we just used the logic of nature to do that process. Build from the bottom up, make sure that the Wood Wide Web gets installed, bank on diversity and on reciprocity, so create guilds where the plants can take care of each other, and create the conditions for animal life to come in. And so to facilitate nature instead of controlling her. So we use zero-till, zero chemicals, and you can see that restoration goes really, really fast. Sometimes it even blows my mind. For instance, when we filled the pond that we created with water, it took aquatic life only 1 hour to be present. I have no idea where they came from, but 1 hour later, we already had aquatic life in the pond. Not everything goes according to plan, though. I have co-designers, like the squirrel who's been planting hazelnut trees all over, but that's also part of facilitating nature, letting nature design and experiment herself. And with very little input, we have a lot of outputs of very healthy food. And I think even more beautiful, we have a lot of biodiversity on our land. Even the swallowtail butterfly, which many of my friends haven't ever seen in their life, comes and visits the garden from now on. Not everything works perfect. We have a bird of prey that comes and kills my employees, the ducks, or we have deer that sometimes come and eat all the food, so we have no left. But still, it's a beautiful example that in a very short time frame, if you collaborate with nature, restoration and regeneration can go really fast. So to conclude, the solutions to the sustainability problems, they are all around us. We only have to turn on the light and realize actually that the nature of the future and the future of nature are interdependent. So all of this and more examples will be presented in the book that's going to be called Natural Intelligence, and where I bring all disciplines that are inspired by nature together. So that was the end of my talk. Thank you, and are there any questions? There's a question here. Oh wait, yeah, there's a microphone.
Thank you. Very nice presentation. Just one question. You said that the previous owners used to use pesticides on the land. So when you started the recovery, where did these pesticides go to?
Well, we're on sandy soil, so eventually they get washed away with the water, I think. Maybe some are still there, and I have no idea. I didn't do any studies on where the pesticides went, but I think after a while they will be washed away with the water. Another question? There's some.
Hi, good afternoon. Thank you so much for your presentation. David from Lisbon University. Also belong to a permaculture project. So, as a personal perspective, how you see nature, the economic system of nature? What would be the pattern in your opinion?
So, I think that brings me back to the core of what I've been talking about. The logic of value creation in nature is, if you don't add value to your environment, you'll die out. So only the organisms that continuously add value and help regenerate, make the whole ecosystem more healthy, more rich, are the ones that over the long run stick around. So I think we really need to go to an economy where we do that, where we have more interfaces, where we look, okay, how can we shift from degenerative value creation to regenerative value creation? And that's not an easy task, but interface shows that it can be done. So I think if we would massively adopt this, we can really start to heal the planet instead of stealing the future of the future generations.
Thank you for the talk. I only wanted to know if those examples of products that you just show us are affordable for the majority of the people, or is only a luxury actually for rich people in the planet. Thank you.
Yeah. So part of Interface's mission is also to be socially responsible. So they really look at those aspects as well. So they're not only for the greenwashing corporations that want to, they're actually very critical with whom they collaborate. So I can only tell for them how it works. Yeah. Any other questions?
Thank you. It was inspiring, and I'd like to ask one question. The nets that you spoke about that were recycled, they decided in the Philippines and the Cameroon. Why? When there are nets in many other places, what was the enabling there?
Condition. Well, I guess the enabling condition was the innovation consortium that they set up. They collaborated with, I think it was an institution in the UK that had very good relationships with those countries, but they're now expanding into Africa. So it was just a pilot that started there, and actually the project is doing so well that it's a spin-off of Interface, and they are now hoping to scale it across the world. Okay, no more questions? And I think we're done. Thank you for your attention. Oh, someone else? Oh, sorry.
Sorry, just one more question. Regarding the networks project, how does Interface sort of trade off on the carbon emissions if they have to ship the nets back to their facilities in California? Is it a trade-off, or is it, how do they sort of
so they want to be zero emissions, and they are indeed not happy with the fact that they have to ship them. They don't ship them to America but to Europe, because it's here where they can recycle it back into carpets. So that is why they're also looking into, can we set up factories like a forest that store carbon that can actually offset that part of the deal, but that's only temporary. So networks will only last until all the fish nets have been fished up, and then they hope there's a clean world and they don't have to do that anymore. So that's how they try to do that. Yeah.
Okay, I will end with a question also.
Yeah.
2 years ago, we BCST Portugal had the pleasure to have you in a workshop that was full of companies representatives. What would you say to companies? What is the best thing companies can learn from nature? What is your message to them?
Well, the best thing, that's a hard one, because there's so many good things. Well, nature has millions of field tests, so I think it's the best example when it comes to efficiency in all terms, in resources, in energy, and it's much more fun also to go out and to look how does nature do this. And actually many of the companies that I work with, they are really motivated, because it's a whole new way of creating things, of thinking about things, and so it's just much more fun than the conventional way as well, and it produces very good results. So that would be my answer. Yeah.
Okay, Leen. Thanks a lot for this session, and thank you all for attending this session. Thanks a lot. Bye.
Oh my God, can I take this? Yes. It's your computer.
It's my computer.
Can I use it to just a second? Sorry.